Okay, so now that we've got this into Google Earth, let's do something interesting with it. So, um, one of the things that we need to do that's helpful to do is try to understand the relationship between employees per acre and commercial square footage. Because most cities and most developers understand um, development, commercial development, in terms of commercial square footage, how much building there actually is in their project. But travel models don't care about how much building there is in the project. They care about how many jobs there are in the zone. That's how it generates trips to the zone, is based on the number of people and jobs that are there. So so we have to have some sort of relationship. So let's take a look at this zone here that says it has 58 jobs per acre. Now, I'm not sure, maybe we got 3D buildings. I don't know if there are any 3D buildings in Logan or not. Let's see. Doesn't look like there's really anybody's put any effort into 3D buildings for Logan, so we'll turn that part off. But knowing this place, these buildings, a number of them have 2 stories. Maybe half of them have 2 stories, but almost none of them will have 3 stories. So that's one thing to think about. So we're going to do what's called a floor area ratio, and it's going to be a rough guess because I don't have the right tools in my free version of Google Earth to do this, but I have some tools that can get me close enough. So what I want to do is go back to the Excel spreadsheet that we've been using, and I'll minimize that so we can see it. And I'm going to create a new spot, and I'm going to just measure some of the I want to measure. I think I want to guess at the floor area ratio. So the floor area ratio is how much commercial floor space there is relative to the amount of land that there is. So a ratio of 1.0 would mean that we could take all of the 2-story buildings that are in here, take the top level off and stick it over in the parking lot and over the roads and everything, and we would end up with exactly the same amount of acreage, so the number of acres. So I'm going to compute over here a commercial square footage. So there are 43,560 square feet per acre, SF per acre. That's how many square feet are in an acre. And so if I had a 10-acre block, that's what downtown Salt Lake's blocks are. That does not include the streets, I think. That just is the interior portion of the block. Then we would have this times 10 would mean that there would be 435,000 square feet of space on the block, and that would be a FAR, floor area ratio of floor area. That's the same thing, of 1. Why is that? Because I have this much floor space divided by this much square footage of land. So does that make sense? Let's see. Alright, so I've now moved to downtown Salt Lake to the Gallivan Center, the Wells Fargo building, Utah 1, Marriott. So there's some of those things here. So let's see if we can take a stab at the floor area ratio of this block. So I'm going to measure in feet from kind of the center of one road to the center of another road. That's 800 feet roughly. Let's see if it's the same over here. Here to here, 795. So that's 800 feet. So let's put that into our Excel spreadsheet and see what. Alright, so I've put in some of the numbers. We've got 800 foot long and 800 foot wide, which means that if I multiply those together, I've got 640,000 square feet per block. Is that right? Yeah. So now I know that there are 43,560 square feet per acre. So if I take this divided by this, I know how many acres per block I have. So there are 14.7 acres per block. Now downtown Salt Lake actually has 10-acre blocks, so they claim and brag about, and but we've got almost 15 here. So what's the difference? Let's figure that out. So if I go down here to the sidewalk level and try and measure what's in the actual right-of-way, I've got about 669 there. Let's see if I come up here to about the back edge of that sidewalk and come to roughly the back edge of this sidewalk, 675. So why don't we just assume 675 is a good number, and I'll put that. Okay, so when I put in I took out the streets and did 675, I then got to 10.5 acre blocks, which is pretty close. That's much closer. So let's just see what that is. That means that if I take this over this, that's 71%, and then I gotta go equals 1 minus that, 28. That means that 71% of the land in downtown is kind of developable, and a full 29% of the land is dedicated to public right-of-way in most of downtown. That's pretty big. That I didn't know it was quite that big. It seems like 20% is pretty typical in a lot of places. This is almost 30% of land in downtown anyway is dedicated to the public right-of-way. So substantial. Okay, so let's estimate the commercial square feet of this Wells Fargo building, just because. So here we go. So we take our measuring tool and measure that it is 300 feet long, roughly, and 119 feet wide, and it is triangular somewhat, so it's not going to be quite that long, but I can take this little triangle piece here and attach it to that little piece there, and that's like making it more like 210 feet wide by 113 feet wide. So let's put that down. So I'm going to write that down over here. So Wells Fargo, 210 by 112, I think I said. And so that's going to be this times this is this many square feet per floor, so 23,000 square feet per floor. And most of those buildings are not a lot taller than 20 stories. That one might be 23 or 24. Let's say it's 24 stories. And that means that it would be that's 500,000 square feet is roughly the size of that building. now, um, now we can make an estimate of how many jobs are in that building. So these are some rules of thumb that we use. Dr. Ewing will know more about these rules of thumb, and they're published in other places. But 330-ish square feet per employee in office settings is typical, and 500 SF per employee in retail settings is typical, and more like 1,000 is typical in industrial settings. So given that this is a office building, then we can say that if I have 500,000 square feet and I divide that by 330,000, then I have this many people who work in Wells Fargo building. That is more people than live in my town of Richfield. I grew up in Richfield, Utah. Well, not more than live in the town, but my whole town was about 6,000 residents, and probably had pretty close to one working person for every 3 people. So that would be equal to that, divide 3. So Mike's whole town works in this building. Pretty cool, huh? This will be interesting. This is ground zero in New York City. Let's see how large, how many people worked in the World Trade Center. So here's one of the building footprints. It's about 183 feet wide. So back to our spreadsheet. So 183 by 183 equals this times this. So SF per floor, and I believe that those 2 towers were about 110 floors each. So that would be this times that. That's let's put the commas on there. 3.5 million square feet in the building, and there were 2 of them. Well, let's just do the employees first. So now if our 330 rule is true here, then that means 11,000 people worked in each of the buildings. Workers per building. So times 2, and that's the 2. Now I went there on tour when I was 18 years old and stood on top of those buildings, and I remember quite vividly that they told us that 50,000 people worked in the World Trade Center complex. So that's considerably larger than this. So maybe they had fewer square feet per employee. I'm not exactly sure. But there were 7 buildings, as I recall. At the time I only thought there were 2, but there's 7 buildings, and I'm not sure how tall the other ones were, but anyway, kind of an interesting little comparison. So by the way, 50,000 people, if that's true that many worked there, downtown Salt Lake probably has about 70 to 80,000 employees, depending on how you measure downtown. That's how many employees there are in the entire downtown. So just those 2 buildings had, getting, or that site anyway, had the majority of downtown Salt Lake working on the site. Okay, back to Logan. So I'm going to say that this spot with these 3 blocks in it appears to me that roughly half, maybe 40% of the land area is covered by a rooftop. And given that those buildings are typically 1 story to 2 stories tall, so let's go back to the spreadsheet then and make an estimate. So if I say 0.4% of land covered, and if I say the average building height is 1.5 stories, then what does that do for me? So that means that if I were to take the 1 story and then the half a story typical on the others and unstack them and spread them around on the land, I'd end up with a 0.6 of land covered, which is the same as floor area ratio. So that's a 0.6 floor area ratio for that zone. Now let's try and guess at how many employees there would be in that zone. So first let's get some statistics about that zone. So we're going to want to know how long it is, so from edge to edge, and since it's kind of not a normal shape down here, I'll go to about halfway down. It's 1,935 by edge to edge, 1,935 by 709. So got to remember those numbers. Let's go over here. 1,935, 709. Long, wide, and so that means then if I take this times that, then I have this many SF, and if I take that divided by 43,560, it's a good number to memorize. I have that many acres in the zone. So, alright, so that's how many acres I have in the zone. So now let's do acres that are covered by rooftop, acres of square footage. That's going to be equal to 31 times what I figured out my floor area ratio was, 0.6. That means I have basically this many acres under a roof, and this acres of floor, I guess. And then if I divide that by, or I multiply that by 43,560, that means I have this many square feet of commercial space in the zone, probably. And so 800,000 square feet, that's kind of a lot. So now let's see if we can figure out how many jobs that is. So this is a combination of retail and office type jobs in that area. So why don't we go with a number that's kind of like 400. So if we say this, divide by 400, oh, I just put a magic number in there. Let me not do that. I'm going to say 400 is average SF per employee, and I'm going to call it a guess, because otherwise when I hand this off to somebody else, they're going to say, what does the 400 mean? And they won't know. So don't put magic numbers into your spreadsheets. Explain them always. So that means now that I think I've got 2,000 employees in zone in 2010. So now, just to see how close I was, if I was a good shot or a bad shot, I'm going to go to my spreadsheet, or I'm going to go back to here and try to figure out what zone that is. So I'll use the information tool. That's the zone right there. It's not stored in here very easily in a way I can see it. Actually, that's the number 1874, but I'll look at it another way. 110 or 190 is the zone. So I'm going back to my original spreadsheet and going to take a look, or going to go to 2010. I'm going to do Control F. That helps me search. I'm going to look for 190, find, and close 1873. So let's see how close I was. That was a pretty good shot. So back over here, 1873, actual answer, and I was this much. I was 10% too high on my guess. Pretty good, really.